Ilo Summary B9. B9. Analyze the structure and function of the cell membrane. Time to look at the structure of the cell membrane. This is basically what the structure looks like if you zoomed really far in. Now where to begin? The majority of the cell membrane is made out of a phospholipid bilayer. The bilayer is where many phospholipids join together, and the hydrophilic heads, which is the phosphate group, forms the head, and it likes water, so it faces out towards all the fluid and liquid of the cell and around the cell. And the hydrophobic don't like water, fatty acid tails point inside so that water can't get to them, and they basically form this protective layer. The bilayer basically forms the general structure of the membrane and determines which molecules can get through. Embedded in the phospholipid bilayer of the cell membrane, there are many little bits and things. To begin, let's look at cholesterol. Cholesterol basically attaches to the phospholipids to help the structure and support it. It basically stops it from breaking down if it gets too hot and turning into this big goopy mush, or freezing up and becoming 100% solid if it gets too cold. It keeps it at a happy medium. There are also glycoproteins, which have attached carbohydrate chains and act as cell recognition proteins that basically grab things that need to come into the cell and are like, hey, you can dock here. Woo! And glycolipids attach to the phospholipids and do similar things. And finally, there are also many proteins within the cell membrane, and they have a variety of different functions that I will briefly go through now. There are channel proteins, or carrier channels, which basically allow certain molecules to travel freely through the membrane with no strings attached, hopping the border. There are receptor proteins that are shaped in such a way that specific molecules can bind to it and be transported through. I don't really have one drawn here because I ran out of room on my board, but yeah, they do. They're like, they do cool stuff. You get the point. There are enzymatic proteins that catalyze specific reactions within the cell. They're pretty cool. Again, I don't have one drawn here because there's not enough room on a very small board. And there are also carrier proteins, which they are similar to carrier channels, but they pick certain things and help bring it through as they are needed, as opposed to being freely like, yeah, just do it yourself. They escort. It's pretty fancy. All of these, however, qualify as integral proteins. And that basically covers the structure and, I suppose, the function as well of the cell membrane and all its little bits. The one last thing we have to talk about is, why is it important? The reason it's important is because the cell membrane basically holds everything inside of our cells together, and if it didn't have all of its little features that made it semi-permeable to all the little molecules floating around it, we wouldn't be able to get the nutrients that we needed, and, well, our cells would basically die, because if our cells can't eat, they can't function, and then they die because they can't do anything. And if our cells die, as they make up us, we die, and that would be sad, because we don't want to die, and death would not be fun. As it would be like cell by cell stop working, and then we slowly just lose all function, and Yeah, not pleasant. So cell membranes are very necessary to hold us together and stop us from just being this big pile of goop of like cytoplasmy, nucleusy goop. They hold each little cell in its place, and they allow us to filter many, many things, all the things. And that is why they are so very, very important to us, and we love cell membranes very much. And that is Intended Learning Outcome Summary B9. Hope you enjoyed.